Welcome to the deep dive. Okay, so for months now, we've all been hearing the buzzwords in AI, right? Agents, multimodal reasoning, open source foundations.
Yeah, it's been a lot of talk.
Exactly. But I think the really critical moment is happening, well, right now. This is when those big ideas actually become a working stack, something you can reproduce and, put to work.
And NVIDIA's Jensen Huang certainly set the stage for this. He promised, I think the quote was, an incredible model, completely open source.
He did. And our sources today really dig into how they're delivering on that. We're looking at NVIDIA's huge new toolkit, the Nemotron AI agent family.
Right, this isn't just another chatbot model.
No, definitely not. This architecture, it's built for serious industrial-grade stuff, secure, document-heavy workflows.
So our mission today, for you listening, is pretty focused. We want to unpack basically three key things.
Okay, what are they?
First, the big picture strategy. Why this push for open weights? We'll talk about that flywheel
Oh,
concept.
the flywheel.
Yeah.
Good.
Second, we'll break down the toolkit itself. What are the pieces? We'll spend some real time on the new document specialist, the Neotron Nano2 VL.
The visual language model, yeah.
And finally, the practical side. What are the actual paths you can take right now to deploy these? From just trying it out locally to going full enterprise scale.
That sounds like a solid plan. And what really jumps out, as you said, is that Nemotron isn't just one model.
No, it's a system, a whole system designed to build AI that's reliable, fast, and crucially, agentic.
Agentic meaning.
Yeah,
It does more than just talk.
exactly. These agents can see, they can read, they can pull information, reason about it, and then actually do things. Take actions within your company's specific setup.
That's the leap, isn't it? From just predicting the next word.
To predicting the next action, like filling a field on a form or checking a specific part of a diagram. That's the modern benchmark.
Okay, let's dive into that first point then. The why. The strategy behind making these powerful models open. You mentioned Jensen Huang's analogy.
Yeah, the two factories analogy is actually a really neat way to frame it.
How does it go?
He says every company now basically needs two factories running. First, the one you already have making your products, physical or digital.
Right, the core business.
But second, you need the AI factory, the engine that manufactures the intelligence your business runs on.
An intelligence factory, I like that. And that factory needs tools, obviously.
Absolutely. It needs to ingest your data, fine-tune models, deploy these agent systems into actual workflows.
So if NVIDIA sells the hardware, the GPUs, why give away the high-value software, these Nemotron models? Seems counterintuitive almost.
Well, it's pragmatic, really. It's all about driving long-term compute usage. Think about it. Open weights, clear data recipes, tools you can reproduce. It massively lowers the barrier for companies to even start.
Makes it easier to experiment.
Easier to experiment, easier to audit behavior, adapt it quickly to their own private data, ensure it meets their compliance rules. All that makes companies much more willing to invest in the hardware needed to actually run it seriously.
Okay, so that's where the flywheel comes in. The open models grease the wheels.
Precisely. Developers start playing with Neotron because it's powerful and accessible. And crucially, these models are optimized, tuned to run best on NVIDIA's stack hardware and software.
Ah, okay, so you get hooked on the performance.
Right. Then, when that prototype works, when it needs to go into a real mission-critical production system where you need guarantees about uptime, security, support,
Then you move up?
then you naturally graduate to the NVIDIA NIM microservices, the supported, optimized, enterprise-ready versions, so the open model seeds the project, gets it going.
And the enterprise service locks in the long-term compute demand. Clever.
It's a well-established playbook.
Okay, strategy makes sense. Let's get into the nuts and bolts then. Meet the Nemotron family itself. You said it's a toolkit?
Yeah, a matched set, deliberately designed for reliability, not just, general chat. Think of it like modular components. You've got pieces for reasoning, vision, parsing documents, and safety. The core pillars for any functional AI agent.
Let's start with reasoning. What's powering that?
That's primarily the Nemotron Nano 3 line. These are tuned for efficiency, think running on edge devices, even local PCs.
And the sources mention a hybrid mixture of experts approach. MOE. Why is that important, especially for the edge?
Right, MOE is key for devices with limited power or memory. See, a standard dense model has to fire up its entire network for every single token it generates. That's computationally expensive.
Okay.
An MOE model, though, is different. It only activates a small fraction of its network, the specific experts most relevant for the task at hand.
Ah, so it's more targeted.
Exactly. You get much higher quality reasoning, closer to a bigger model, but in a much smaller footprint. Better speed, lower latency, without draining the battery on your edge device. It's a necessary trade-off for getting AI out of the data center.
That makes sense for local or edge tasks, but for the heavy lifting, especially with documents, you mentioned the specialists.
Yes, the Nemotron Nano2 VL. The VL is for visual language. This is the one built to handle the kind of messy reality you find in most enterprises.
What kind of mess are we talking?
We're talking invoices with weird layouts, multi-page reports, scanned blueprints, scientific charts, tables that span pages, the stuff that traditional OCR just jokes on. The Nano2 VL is designed to understand not just the text, but the visual structure.
And part of that system is Nemotron Parse. That sounds less like a general AI model and more specific.
Very specific. Think of Parse as a production-grade data extractor. Its only job is to take those messy inputs, PDFs, images, whatever, and turn them into clean, structured data. Typed fields, proper tables, machine-readable bits.
So it cleans up the input before the reasoning model even sees it.
Exactly. It's the essential prep step. Garbage in, garbage out still applies, even with powerful AI. Parse ensures the agent gets clean, structured input to work with.
Makes sense. And then you have the safety components, guardrails, RADO.
Yeah, safety guard and enhanced RREG retrieval augmented generation. If you're letting an agent loose on sensitive internal documents, you absolutely need it to be trustworthy.
Trustworthy meaning?
Meaning it stays on topic, it refuses to do unsafe or irrelevant things, and critically, it tells you where it got its information. Citations. The RRE components help ensure the answers are grounded in the actual documents it looked at. That's table stakes for regulated industries.
Okay, let's really zoom in on that Nano2 VL, the visual language specialist,
Yeah.
because this seems to target those really common enterprise headaches. You mentioned documents that break other models.
Yeah, things like tables split across 2 pages, tiny footnotes, complex diagrams with arrows and labels, figures in scientific papers. The Nano2 VL is built for that.
And the key isn't just better OCR.
No, it's OCR plus reasoning. It doesn't just read the words. It understands how those words relate to the layout, to the images, to the charts on the page. The spatial relationship is key.
You mentioned something called tileaware image handling before. What is that? How does it help with big documents?
Right. So imagine a huge high-resolution blueprint or a long multi-page PDF. If you just shrink it down to feed into a model, you lose detail. You lose the spatial context. Tileaware handling means the model processes the document in smaller, manageable chunks or tiles. But, and this is the important part, it still understands where each tile fits in the bigger picture. It keeps the global context.
So it can see the details and the overall structure.
Exactly. And because it understands the coordinates like this number is in cell B4 of this table on page 3, it can give you answers that point right back to the source location. It can give you the bounding box.
That grounding is huge. That's the difference between the AI said so and the AI found this specific number in this specific spot. Much more useful, potentially legally defensible too.
Absolutely. You need that traceability.
So let's talk performance. The sources give benchmarks for the FP8 release on H100 GPUs. What do they tell us?
They tell us it's ready for prime time, basically. For DocVQA, that's question answering on multi-page documents, the Nano2 VL hits 94.3% accuracy.
94.3%. That sounds impressive. What does that mean practically?
It means potentially a massive reduction in how much human review is needed for tasks like checking loan applications or analyzing contracts. It speeds things up significantly.
And visually complex stuff like charts.
Also very strong. On ChartQA, it's scoring 89.4%. And for really technical diagrams, think engineering schematics, it gets 87.6% on the AI2D benchmark. These aren't just lab numbers. They target real enterprise bottlenecks.
Okay, high performance, specialized for documents. This leads to the big question. Access and cost. If I want to use this, how do I do it? You mentioned 2 tracks.
Yep, 2 main paths, depending on whether you're prototyping or going into full production.
Path number 1.
Path 1 is the easy entry, open weights. You go to NVIDIA's page on Hugging Face. You download the model weights. The model itself costs nothing, $0.
Okay, free model, what's the catch?
The catch is you need the compute to run it. GPUs, storage, networking, whether that's your own hardware or cloud instances, that's your cost.
And the sources mention you can get this running pretty quickly for testing.
Yeah, tools like vLLM make it relatively simple to spin up an endpoint, even one that mimics the OpenAI API, often just on a local developer machine with a good GPU. It's fast, flexible, great for tinkering.
So that's the prototyping track. But what happens when it needs to be reliable, secure, always on?
That's path 2. NVIDIA NIM microservices. This is the enterprise route. It requires licensing for NVIDIA AI enterprise software, plus the GPUs, of course.
Why make that switch? If vLLM gets the open model running fast on my GPU, why pay for NIM? Isn't it just the same model underneath? What does NIM actually give you that's essential for production?
It's about the difference between just running code and running a supported managed service. NIM provides the production guarantees. You get stable version APIs, REST and gRPC. You get built-in health checks, monitoring, logging integration. Crucially, you get enterprise security, like proper role-based access control.
And vendor support, I assume?
And vendor support, a clear upgrade path. It handles all the operational complexity of managing GPUs serving at scale that you'd otherwise have to build and maintain yourself. vLLM is great for speed trials. NIM is for when it absolutely has to work securely and reliably 24/7.
Okay, that distinction makes sense. So the advice is?
Start with the open weights. Prove the value. Figure out your workload needs on a dev box or a small cluster. Then, when you need that production stability, security, and support, when uptime becomes critical, you migrate to Nano.
Don't pay for the enterprise bells and whistles until you actually need them.
Exactly, it's pragmatic.
Now, stepping back a bit, Nemotron isn't alone in this NVIDIA open push, right? We've seen other things like Cosmos, Isaac GR00T for robots, Clara for biology. How does Nemotron fit into that bigger ecosystem?
Yeah, it fits perfectly. It reinforces this idea that AI agents don't live in isolation. They need common infrastructure, common standards.
So they share underlying tech.
Often, yes. Things like tokenizers might be shared. They're distributed through similar channels, like Hugging Face. It means if you build expertise using Nemotron for document processing today.
It's easier to connect it to a robot running GR000T tomorrow.
Potentially, yes. Or integrate it with a specialized biology model built using Clara tools. Sharing these foundational pieces speeds up development across the board. It's about building an interconnected system, not just point solutions.
Okay, so if the market has lots of open models now, why specifically Nemotron? Besides the benchmarks, what makes it stand out technically?
I'd point to three main things. First, it's designed for agentic workflows. The components, the VL model, the Nano 3 reasoner, Parse, the safety features, they were built to work together from the start.
So less glue code needed.
Much less.
Yeah.
You're not trying to cobble together a vision model from one place, an LLM from another, and a parser from somewhere else. It's engineered as a system.
Okay, number two.
Efficiency. We talked about the Nano line being tuned for throughput and latency. This isn't just about raw power. It's about hitting performance targets, service-level objectives, SLOs, without needing way more hardware than necessary. It's about optimizing your operational costs.
Makes sense for production. And third.
Trust. Especially now, with everyone worried about AI risks. The transparency here is good. The model cards, the documentation, they detail the training data mixes, the alignment steps.
Why is that so important?
Because it gives your risk and compliance teams the information they need to actually approve using this model for sensitive internal tasks. Without that transparency, it's often a non-starter.
Okay, let's wrap this deep dive with some really practical advice. For someone listening who's thinking, okay, I'm going to download Neotron Nano2 VL today, what are the critical first steps, the playbook for getting production-ready results?
Right, the playbook really leans into structure and measurement. Strategy 1, pre-process relentlessly. Use Nemotron Parse. Turn those messy scans and PDFs into clean, structured data first.
Define the fields, the tables.
Exactly. And the sources really stress this. Ask questions that use coordinates. Instead of asking, what's the total cost? Ask, what's the value in the total cost cell on page 2? Using that spatial information makes the agent's answers much more stable and grounded. Structure the problem for it.
Okay, structure the input. Strategy 2.
Retrieval first, then generation. Don't expect the model to have memorized every detail of every document. Point it at your index document library first. Let it retrieve the relevant pages or sections.
And you mentioned visual indexing.
Yes, critically. Store the actual page images alongside the extracted text or data. This lets Neotron Nano2 VL do visual checks. Even if the extracted text says one thing, the model can look back at the image to confirm the layout, the chart, the context.
Got it. Retrieval plus visual confirmation. And the final strategy.
Measure the right things. Don't just track how fast it responds, the latency.
What should you track instead?
Track metrics that prove quality and trustworthiness. The absolute key one is the answer grounding rate. What percentage of the information in the AI's answer can be traced back, verifiably, to a specific location, a coordinate, a cell, a cited passage in the source documents.
And citation accuracy, too.
And the citation accuracy. Is it pointing to the right place? That's how you demonstrate your AI factory isn't just fast, it's producing reliable, verifiable intelligence.
So pulling it all together, this Nemotron release feels very strategic. NVIDIA uses the open weights to make it incredibly easy, almost frictionless for developers to start building and proving value.
Seeding ground, exactly, lowering that initial barrier.
And then once that value is proven, they provide M as the secure, supported, scalable path to turn that prototype into something enterprises can actually depend on.
That's the bet. Nemotron is basically an invitation. It's saying to engineering leads, to product managers, stop thinking about AI agents as research projects or cool demos. Start treating them like the industrial software systems they need to be.
So what's the final challenge, the provocation for our listeners?
It builds right on that factory analogy.
Yeah.
The time for just playing around with prototypes, well, it's kind of over if you want real impact.
Get serious.
Get serious. Take the Neotron Nano2 VL, download it, run it on your dev machine, point it directly at the ugliest, most complex chart, or the messiest stack of invoices that slows your team down right now, the stuff humans hate doing.
And then
Measure. Measure that grounding rate. Measure the accuracy. Don't just see if it works. Quantify the value it delivers by reducing that human friction, that error-prone manual work. The challenge is this. You needed to build that second factory, the AI factory. And now, NVIDIA has basically handed you the industrial-grade, open-source blueprint to start doing it. Do it in the open.